Hello, today lecture is about Unit 4, the Geospatial Technologies, their concepts, techniques and components for generating the valuable agri-information. Let's see. First thing is the disclaimer. I try my best to explore the concept, but I am not an expert regarding the topic, technologies and method being discussed in this presentation. So this is unit 4 of the syllabus and it is the topic highlighted here, the geospatial technologies. The first thing in this chart over here, it is the chart from 1960 to 2013, and the chart is showing the declining in the area of the agricultural land in India. It is saying that over the year from 1960 to 1990s, the area for agricultural land was gradually increasing, and since then the available land for agriculture is decreasing. So there is a constraint of reduced agricultural land, and there are another challenges being faced by the agriculture industry of India. First one is the urbanization, that is more and more houses are being constructed, the commercial real estate, buildings, etc., causing lot of agricultural land to be converted for the urbanization. And second issue is the increasing pressure on the natural resources. The natural resources, as we knew, water, the most important natural resource, for the agriculture, plants and animals is crucial, and the amount of water required, amount of other natural resources required for agriculture are being consumed more and more. The third challenge is the food demand. As the population is growing, the demand for the food products, agriculture products, is growing, but the production of those products, there is a challenge to meet the supply and the demand. And the third last thing is the climate change. Due to lot of factors, the climate is changing. The rain is not adequate in the rainy season. In the winters, the temperature is going extreme, same in case of summers. So there is some climate change as well, a challenge, kind of challenge faced by the agricultural industry in India. And this is something, a report saying there is increase in demand across the world population for agricultural products, and the demand for food was also expected to rise by 60% at the near around 2012. And this is the climate change, the concept also discussed earlier, like there are certain regions where there is heavy rainfall, or there are certain regions where rainfall is not adequate, and there arises issues like floods, drought, and changes in climate also affect the pest and diseases, and the nutritional content of the food got also affected. And there are some resource constraint like the water and the land. These are the limited natural resources for the required for the agriculture purpose, and the pressure on these resources is also increasing day by day. So the next slide is, this is the model, a representation of the challenges in agriculture, and we are going to use some kind of technologies to fight those challenges. And this is the current scenario, as the income level as compared to 1960s, 1940s, 50s, the income level of the per capita per person is increasing, and there is increase in population, and it is estimated that around 2050 the population of India would cross about 9.1 billion, and as the population is increasing, the per person consumption of food is also increasing. The people nowadays are consuming more food than prior to 2040 or 60 years ago. So this causes some challenges. The first challenge is the urbanization. There is a demand in population, and that population needs some shelter for rest, some departments, some buildings to work, like industries, medical, healthcare facilities, hospitals, roads, and all those things requires land. And this is also challenge, urbanization. And second challenge is the climate change, and also increased pressure on natural resources like land, water. So what is the solution to these three challenges? The solution is the automation, that is to make use of technology in agriculture to perform kind of repetitive task with the help of machines, and there need to be some kind of collaboration between humans and machines. This will result in higher productivity, and to provide this kind of automation, there are some geospatial technologies and tools for various agricultural activities. There are some sensors here, we call data sensors for soil and crops, and there are some precision techniques for seeding, sowing, use of fertilizers, insecticides, and pesticides. There are other concept tools like drones, unmanned aerial vehicles, and sensors like GPS, GNSS, and farm mechanism control machinery. We will discuss these later on. So this was the rough idea, the current scenario, the challenges, and the solution we are going to find with the help of our geospatial tools and technologies. And this is basically the theory of the previous slide we discussed. You can go through this theory, and this is the figure showing use of geospatial technology and how it plays an important role for the precision farming. And you can see right here the layers. This is the agricultural land, and its various layers it is divided into, and here is some kind of machinery on the land, and these are the satellites over here, this one. And but these machines are doing here, the first thing is the this tractor, red tractor over here, it is collecting the samples from the soil, and for cultivating the new crop, the soil samples are being sent from this instrument to this satellite, and it is connected to the geospatial technologies over the cloud, over the internet. And so all the samples from various locations from this field is collected by this tractor. And the second one, this thing here, and it is supplying the fertilizers with the on the basis of the previous samples data provided by this red tractor. That is, if there need to be improve some kind of efficiency for cultivation of a new crop, then this blue vehicle is supplying some kind of fertilizers. And after the field is ready for the seeding process, this third vehicle over here, we are using the machine to plant the crops over the wide area portion of this field. And as the time progresses, the crop grows, and here is this person is performing the scouting inspection, manual inspection of the crops, and recognizing if there is any kind of disease or pest control need to be performed. And all these machines and this person is interconnected with the help of geospatial technology. So the data is constantly being recorded and maintained on the servers. And this last stage is the harvesting stage, and this is also being performed with the help of machines. And later on we will discuss how the heat map, this is the heat map, how this thing is used in geospatial technology. But this is the simple example of precision farming done with the help of geospatial technologies. And these are the range of applications of geographic information system, geographical positioning system, and remote sensing in agriculture. First is the precision farming. You can use for disease control, for crop forecasting, and there are a lot of other areas like agriculture, pollution, irrigation. You can use these technologies. And these are the heat maps. What are these telling? Let's see. And the first thing is, these heat maps are being taken by the NASA aircraft flying over this Maricopa Agricultural Center in Arizona. And these are the images captured by the some kind of drone in US, Arizona. And from these figures, the first one here out here is showing vegetation density, and second figure it is showing water deficit, and third one is crop stress. So these false color images demonstrate some kind of application of remote sensing in precision farming. And what these colors are being trying to provide information is that you can see here the dark blue and green less vegetable. Okay, the dark blues and dark green indicate less vegetation. Okay, the red shows area of bare soil, Okay, and the middle is the map of water deficit derived from this, and temperature measurement. The greens and blue indicate wet soil. Okay, red are the dry soil, and the bottom image where crops are under serious stress is particular case of field, and indicated by red and yellow pixel due to irrigated. So let's see what is happening over here. This first image over here, it is showing the vegetation density, how could in a particular area how the vegetables or crops are close together, and in which area these are planted. You can see the blue region out here, the density is higher. Similarly for green region, the density is higher, rest the density is low. And the second figure out here, it is representing the water deficit. In the red region there is lot of water deficit, and but in yellow and green region there is some water in the field. And this third heat map is showing the crop stress. If there are lot of crops packed in a small region, then it induces some kind of a stress on the crops, and it is represented here with the dark blue region. There is lot of stress. Similarly in yellow region we can see the different crops having stress level. So next thing the question arises are, what are the common geospatial technologies? There are generally three geospatial technologies. First one is the remote sensing, second one is the GPS, which we call global positioning system, and the third one is the geographic information system. We will discuss with them one by one, but in a brief, let's see what is remote sensing. It is in this technology we collect the images, aerial images from drones or any kind of unmanned aerial vehicles, kind of images taken by the drones or any other flying devices. And what is GPS? As the name suggests, it tracks the location, your location coordinates, longitudinal or latitudinal coordinates on the earth. Where is your location? And this GIS, Geographic Information System, it is a kind of a software system which analyze, store and manage all kind of spatial or geographical data. Basically these are the softwares which will process those images, right? These images were generated using GIS software from the remote sensing images collected by the drones. So GIS are the technology and basically the software which process spatial and geographical data. First thing is the being discussed out here is the remote sensing. What is remote sensing? The acquisition of information about an object without making a physical contact. Like you can capture the photograph using any kind of sensor, we call this remote sensing. Similarly, if you can check the temperature of any object, any crop plant without making any physical contact, this is called remote sensing. Basically there are two types of remote sensing. First one is the passive remote sensing and second one is the active remote sensing. And what is the difference between active and passive remote sensing is that this is the satellite, or it could be any drone, UAV, unmanned aerial vehicle, and the objective here is to collect. This is our land, our field where crops are cultivated. We need to track or capture the photographs of this particular region and send those to our station, ground station. And so in case of active remote sensing, this satellite is particularly fixed over this region for 24/7. Means for every minute, every hour, the satellite is fixed at this particular location, and it is sending images, captured images, constantly after a particular interval. Could be a 30-minute, say after 2 hours, it is continuously sending the images and actively monitoring this location. But in case of passive remote sensing, we can set the to the satellite that you need to just capture the images after a 10-hour interval or 2 days interval, 3 days interval, etc. And these are the vehicles, tools for remote sensing: helicopters, the planes, the satellite. And this is the kind of aerial image being captured by these remote sensing tools or vehicles. And these are the satellites, different kind of satellites: Aura, Parasol, Calypso, CloudSat, Aqua. And you can see these satellites are being used for capturing the aerial images for the Earth surface. And this is another classical example. Here the satellite is observing the various regions, ocean, the ground, and all these things are interconnected. And inside here we are having the base station where all this data is being kept and processed and being collected from all these technologies. This is the GIS image generated. On the right hand side you can see the heat maps. These are generated by the GIS softwares. And on the left hand side, this is the aerial image of a particular region. And generally this research was conducted at this university, and it just captured this aerial image of particular location. And with the help of our geospatial technology, GIS, we are just constructing a heat map where we can clearly see in the red region, the red region out here is representing the houses, and the trees or bushes are represented by this green region, and the lawns are by light green, and the shadows where enough data is not available is represented in this heat map with the black color. The next thing is geographical information system. As we said, this kind of heat map is generated using GIS software from these aerial images. So it generally analyzes, it processes, stores, collects any kind of spatial data, whereas GPS track the location of the object over the Earth surface. And for this it uses the latitude and longitudinal coordinates. So GIS is the software basically, and GPS is the technology, hardware technology generally. And these are the examples of GPS and GIS. In case of GPS, it is saying that the agriculture producer can use the handheld GPS receiver to determine this location in a particular field and vineyard. Whereas in case of this GIS, the following heat map are generated to check any kind of chemical spill and any kind of pest attack, crops, regarding any kind of information can be generated. And this is the all software, and this is generally GPS is the hardware. And what are the concept of map layers? Map layers. GIS, as we discussed earlier, the software GIS database create layers with many pieces of information for the same area. And what generally takes, it take the geospatial image and processes it in forms of these layers. And in this case, this bottom portion, it was the actual aerial photo of the area, and after analyzing this portion, this aerial photo, the GIS software constructed the topsoil layer, this one, and the yield data was shown in this layer. So in form of layers, all this data is stored in this database. And this is the heat maps for AP, Arunachal Pradesh, and generally these heat maps were used during 2003 for monitoring the weather parameters, that is the maximum and minimum temperatures from the month of fifth month is January, February, March, April, May of 2003, various dates from 27, 28, 29, 30, 31. For the 5 days, the whole Arunachal Pradesh state area is being monitored with the help of geospatial technologies, and the heat map is showing the temperature. The red zone is where the temperature is above 48 degrees Celsius, and this yellow zone represents temperature between 42 to 44 degrees Celsius, whereas the less than 38 degrees Celsius temperature is represented by these blue and sky blue zones. So with the help of geospatial technology, we constructed the heat map which representing various areas and clustering them on the basis of temperature. So if we collect such kind of information, we can plant those crops which require relatively warmer temperature to grow, and plant the crops in those regions. Similarly, for those crops which require lower, warmer, or I can say the colder climate to grow, we can select those regions which have the climate with the colder climate, I can say. And this thing is the monitoring rainfall and its deviation in Telangana district from 6th month to 30th of 9th month 2014, and it is right here showing the monsoon season ending, and you can see this blue region over here. It is showing that in this region the monsoon rainfall is 20% extra, and in these red zones the rainfall is limited or there is scarcity, and in this yellow regions the rainfall is as usual. So we are just tracking the regions where the rainfall is excess, where the rainfall is normal, and where we found the scarcity of the rainfall. From this acquired information we could plant the crops accordingly, and it will help further. And this heat map, it is showing the fragility of soil. So there are some issues related to soil degradation, like erosion by water erosion by wind, and its deterioration by chemicals, and some kind of physical deterioration, etc. So all these degradations are represented by the heat map. You can follow the colors like magenta representing water erosion, the orange representing the wind erosion, and the physical deterioration is represented by this purple color. And there are regions, stable terrain, this blue one, and non-used wasteland represented by this skin color, etc. So we can classify the land with the help of these GIS technologies. And this is another heat map of Andhra Pradesh, and with the help of this heat map we are monitoring the drought, and the regions, all these blue regions out here representing that there is no drought, and the red regions out here representing severe drought. So with the help of this information, if we collected you can see this information was collected from June of 2012 up to September of 2012, we can plant our crops accordingly, and we can take the informed decisions which region would be best, and if there are some crops which are water sensitive and require more water, we can plant those crops in those regions where there is no issue of the drought, and vice versa. Next is this heat map is showing regions of West Bengal for the progress of rice transplantation, and this regions from here, the green part over here are the rice transplantation process from 15th to 30th June, and yellow part this representing from 1st to 8th July. Similarly for different time frames, we can see this rice transplantation part in this West Bengal and in the part of Odisha. We can closely monitor with the help of these charts. And this is the heat map for the crop damage, and there was the super cyclone in Odisha which caused the damage to the crops, and here is the heat map for the flood affected rice area, and we are making the assessments, various assessment over here in the Odisha with the help of these geospatial technologies. And these heat maps are for the Kharif crop of Telangana district, and basically we are forecasting the crop yield, how much crop would be for upcoming years from these regions. And here we are having heat map of 2011, 2012 and 2013, and here the legend is showing this region. In this chart all is color is red, meaning the yield is greater than 15%, and for the year 2012 if we plant here our rice, so only above 50% is these regions. And similarly we can estimate the crop estimate of if we have previous data for the year 2012, 13 and 11, we can project the estimate for upcoming years and which region is best for this particular crop, say rice or wheat or corn, and choose that particular area where we get the maximum yield. And this kind of forecasting could be easily done with the help of geospatial technologies. And the next uses is this monitoring of pest and diseases among crops. And these are the regions, purple regions over here. They are representing some kind of a pest and disease hotspots, and these hotspots were identified with the help of geospatial technology and the Andhra Pradesh. And the regions are this Godavari district and Nellore districts. These are the regions which the technology hotspotted, and we can offer some kind of advisories and can also target these vulnerable areas for rectifications. And this is the heat map for particular area of a plot, and this purple line showing bare soil and green is the plant shadow. The crop in this area of land, someone has planted blueberry plants, and the red region over here showing blueberry plants, and the green one is showing the grass and small shrubs. And similarly this region over here, the blue one, the green one representing blueberry plants, and so on. Next thing is what are the benefits of usage of geospatial technology in crop life cycle at farm level. That is, if we use the geospatial technology at the farm level in crop life cycle, what would be its advantages? So let's see the steps in crop life cycle, that is the site selection and soil preparation. These are the first step. If I want to cultivate some kind of crop, I have to select the best site for its plantation, and I need to prepare the soil. So how these two challenges, or I can see these two operations can be done with the help of geospatial technology. It is saying that the GIS based maps, which we discussed earlier, are instrumental for assessing farm topography and demarcation of boundaries. With the help of these maps we can assess the farm topography and also outline the boundaries. And second thing is we can capture the moisture level, the texture, type of soil with the help of high resolution imagery collected by the geospatial technology. The tilling, plowing equipment and machines, we can make use of GNSS, a site specific geospatial technology with these operations. And with GPS enabled laser levels, the guided laser beam throughout the field help the farmer save water, reduce weed problem, and improve uniformity of crop maturity, and we can reduce the irrigation time with the help of GPS enabled laser levelers. So these are the geospatial technologies which can help during crop life cycle phase in the earlier phases, that is site selection and soil preparation. In case of planting, within the planting phase, the technology which can help here are the satellite navigation guides, implements like planters, drills, and machinery like tractors. These provide mechanical or hydraulic electric power implements to perform wide range of crop production operations. And there are some geospatial technologies which support organic farming method to find the most profitable and healthy places to plant new crop. With the help of these geospatial technology, the places where we can plant most crop and that regions would be profitable could be selected. And the next thing is the precision farming. And you are the agriculture student, you might have known this precision technique better than me. So GNSS, it is the geospatial technology. It can help in the precision farming. This will allow farmers to reduce cost and optimally utilize the available land and the resources. So in the nutrition management phase, we can use the high resolution satellite images to reflect the various type of patterns in different stages of its growth of plant. And there are some kind of if there any kind of erosion, any kind of drought and other issues, we can easily monitor and take preventive steps. With the help of this hydrospectral remote sensing, we can do soil profiling and we can apply the fertilizers only to those regions where it is required. And with the help of this GNSS enabled devices, we can use for the tractor guidance and crop scouting. And this is the GNSS enabled precision farming. This can also be used while we are spraying and applying any kind of fertilizers to only appropriate location, not whole field. So next thing is the pest management. In case of pest management, we can apply the pesticide with the help of aerial images are there provided, and these pesticide can be applied using satellite navigation and only to the certain regions, areas where there is a demand, and those pesticide can be applied using unmanned aerial vehicles where it is not easily, the ground is not easily accessible. And the satellite imagery enables better utilization of a pesticide, and also it helps in early detection of some plant diseases and plagues with the help of satellites. So satellites plays very important role in pest management. Next, for water management, and we can use the GIS based maps, and with the help of these we can find the effective solution for removing excess water from the soil, and conversely for water conservation we can use GIS based maps. And for better management of water resources, GIS tool can be used with the satellite imagery to assess the natural vegetation, etc. And for the harvesting, this satellite information can be used to monitor the yield, and we can also track the earlier stages of growth of the crop. And also there are advantages of advanced sensor technology which enable us a precise crop monitoring and harvesting. In the storage and distribution phase, the GIS technology can help to analyze the distance to the market, the distribution point, and the mode of logistics. Similarly, with the help of this technology, we can find the better location for warehousing facility and to ensure the crop protection from the public areas. So this is the simple table, and it is showing which technology. These are the geospatial technology: earth observation, GNSS, hydro and soil sensor, laser, and G-powered mobile apps, GIS. Which technology can contribute to which part of this agricultural activity? For example, for harvesting, the GNS technology can help. Similarly, for storage and distribution, the GNSS technology is the best. And if we want to do some kind of a pest and a weed control, we can use the earth observation technology, and there is no other technology. Similarly, for water level adjustment, we can use hydro and soil sensor, G-powered mobile apps, and GIS. And these are the technologies which are discussing what is laser leveling. With the help of laser leveling, we can reduce weed problems. We can effectively use our water resources, and we can help to improve uniformity of crop maturities. So there is, if in a field we have planted the rice, there could be certain regions where the growth is lagging behind than the rest of the field. So we can do this. Precision seeding and crop monitoring, you can read. And this is the precision harvesting. It can also be done with the help of these technologies. And this chart over here representing the use of geospatial technology in agricultural industry, and this worldwide data is collected for some regions of European countries, and here we can see which technology is used. This darker green region representing least used, and this light green representing widely used and somewhat used. So you can see this GIS is about 60% used in the all around the world. Then there is this GNSS, then satellite images, and then aerial images. And next thing is, what are the softwares used for these geospatial technologies? So this pie chart is showing maximum 87% of the softwares are proprietary. Proprietary generally means that they are not free to use. They are the property of some companies, and you have to pay for those companies in order to access those software. It could be one-time payment, or it could be yearly subscription. So most of the softwares in this field are the proprietary. These are not free. And this is the geospatial technology in Asia Pacific, and most of the technology in this Asian region is the GIS, then followed by this GNSS and satellite imagery, and then aerial images. And this is some theory, and this in particular related to India, the mostly we are using GIS, geographical information systems, like earlier see the heat maps, and then the satellite imagery and aerial images. These are the geospatial technology right now we are using as of 2015. This data is older, captured and maintained here older. These numbers might have been changed, but it was taken in 2015. So next is the use of geospatial technology in India. And in India, generally the remote sensing GIS are widely used. And what is the future of geospatial? You can read the definition. Generally, the help of precision farming, there is some growth we can see out here, and there is technology lidar, and unmanned aerial vehicle is also being increasing. But this slide is representing here, these are the challenges of geospatial technologies and usage in agriculture sector. What are the challenges to implement these technology, to use these technologies in agriculture sector? First, the major challenge out here is the high cost of the hardware and software. So the GIS technologies, we need some kind of sophisticated software and we need some kind of hardware, so the cost associated with them is higher. This is the major challenge to acquire or implement these technology in agriculture sector. The second challenge is the lack of skilled manpower. We don't have enough training programs, enough skilled people to operate those geospatial technologies, so this is also the challenge. The third challenge is the inadaptability by the people at grassroots level. So people are hesitant to adopt newer technologies at the root level, and they are using their traditional method which they think have worked in the past and would be useful in the future too. So they are just not grasping the newer technologies. So rest you can read from yourself. And this next slide, these are the organization related challenges for geospatial technology usage in India. So the first major challenge is we are having the lack of skilled manpower in India. Who those persons which are good and capable of handling these instrument and geospatial technologies. The next major issue is there is a lack of clear geospatial policies. And what are these policies? These policies are the set of rules and which are governed by the central government, state government regarding the use of this policy, and these particularly there are not more policies framed, and these are unclear, causing issues and challenges, like on which region we can fly drone, and what kind of sensor image, satellite imagery from here. There are a lot of policies which are need to be framed. The next challenge is the communication gap with the organization, industries and the farmers. This is also communication gap. There are new technology but farmers are not aware of them, and also the training programs being organized, there is need to be adequate participation. Similarly, on the adoption level in India to adopt the geospatial technology, the challenges are the first is the high cost of technology. The cost of technology is much higher, so most of the farmers are not willing to adopt to these technologies. The second challenge is the as we discussed earlier, inadaptability. People are not adapting these new technologies because they are comfortable in using their traditional method of farming. Rest you can read yourself. And data related challenges related to adoption of geospatial technology in India, these are major one are the lack of recent satellite images. We are not having access to the recent images, aerial images provided by the satellite, and there is also lack of topographical real-time data, and these are also the challenges. That's all. If you have any queries, let me know, and that's all. Have a good day.